This is FortiAnalyzer day 2. So on day 2, sir, we'll be continuing with their administrative access. We'll talk about monitoring administrative events and tasks. We'll talk about high availability also. So when you talk about administrative access controls, right? And monitoring, what do you mean by that? Let's talk about this. Monitoring administrative log status. So whomsoever monitor the current logged in administrator accounts. Like this is pretty much like your RBACs. Okay, this is pretty much your RBAC, role-based access control. Identify logged in user by a green check mark next to their name. You can see that on this particular slide. By default, the list is available to administrator who is having a super user access, right? So those who have the super user access, they can see and have a visibility for those particular users who have logged in. Viewing administrator event logs. In FortiAnalyzers, event logs can be seen which user has generated what event, login failed, logout, login, logout, these particular different types of users, their time, which device ID, and their performed ID, where, with what they have done it. Monitoring task. View task FortiAnalyzer administrator has performed, including the progress and the status. By default, the available only to the administrator. Again, the same thing with reference to the super users. So super users will be able to monitor the task, what is happening inside the FortiAnalyzers. You can also see FortiAnalyzers also allows you to monitor FortiGate administrative login activity through FortiView. If you want to see that, FortiView is an option. In the analyzer, you can see this. The failed authentication attempts page shows failed login attempts. How many failed attempts are there to log in into the FortiAnalyzers, and includes the source IP address of the login type, the interface, and the number of the failed events, like console or HTTP, how many failed attempts, login type, admin, source IP addresses, and so on and so forth. Finally, the FortiAnalyzer allows you to monitor administrative activity again with the help of the FortiView. This is predominantly with FortiView, the system events, right? This option is basically we can see the system events. Page shows all the system and administrators invoked events. To see more details about an event type, just you need to right click on that, select view related logs to go to the corresponding sections in log view where more information is available, and you can have a thorough inspection to that or monitoring to that. Just for the knowledge check, in order to view the FortiGate event logs on FortiAnalyzer, what configuration is required? So the answer is FortiGate logging settings must have event login enabled. If an administrative user's job description required them to manage devices but not the system settings, what is the most appropriate default administrator? Standard user. Super user when you need full read and write access. Let's talk about, sir, high availability, important topic. The objective for this session will be understand FortiAnalyzer high availability, configure HA, understand the load balancing, synchronization, and firmwares. When you talk about FortiAnalyzer HA, so FortiAnalyzer HA provides the following. Provides real-time redundancies in case of the FortiAnalyzer primary device fails. If the primary device fails, the another device in the cluster is selected as a primary box. Simple. Second, the synchronizations or synchronize logs and the data securely among the multiple FortiAnalyzer devices. So logs and data will be synchronized between the members of the HA cluster. System and configuration settings applicable to HAs are also synchronized. Okay, system related configurations applicable to HA are also synchronized. It elevates the load on the primary device by using secondary devices for processes such as running reports and all. So some of the processes you can run on this box, some of the processes you can run on this, and on this, something like that. This is two are mails, so one is primary, another one is secondary. Question: how many devices can participate in FortiAnalyzer's cluster? So the answer is you have 4. So FortiAnalyzer HA cluster can have maximum 4 devices in a cluster. One of the box among the 4 will be primary, and another 3 will be consuming the role of secondary devices. All the 4 devices must have same series of the FortiAnalyzer, same firmware, and be visible to each other on the network. That means reachability should be there. Reachability among all 4 should be there. All devices should also run in the same operation mode. In previous lecture, we have discussed about analyzer mode or collector mode. If you are running one in analyzer, all remaining 3 should be in analyzer mode, or if you are running in collector, all should be in collector mode. Although the one thing which can be mismatched is the disk allocated. Allocated disk can be a mismatch, fair enough. It is important to ensure all cluster members have enough storage to accept the logs. But it is best practice that all the 4 available devices in a HA cluster should have the same storage. So when you are using FortiAnalyzer as VMs, so when you are using FortiAnalyzer as a VM or as a cluster member, all VMs must be same also, same platform. That means the VM which is running on ESXi and you are running VM on the KVM or Hyper-V by Microsoft, that also cannot be done. Their platform also should be same. So all VM should be running on same ESXi's only. Very important thing, FortiAnalyzer, when you are deploying in a cluster or in an HA implementation, works only in the network where you are using the concept of VRRP, Virtual Router Redundancy Protocol, and where this particular protocol is permitted. Therefore, it may not be supported by public cloud infrastructure few of the times. So in this particular diagram, so that's the reason, sir, you see that on top it's written the VRRP concept. HA options. In system settings, HA, use the cluster settings. This is cluster setting options to create or change the HA configurations. To configure a cluster, start with select the operation mode of the primary device. So say, for example, HA you want, by default, 1 is running. So it's a standalone. If you go into the system setting HA, you have an option of HA, high availability, primary and secondary. Over here, you can choose it up. Select the preferred role for the device when it joins the HA cluster as per your convenience, you being the administrator of the box. In the cluster virtual IP address, this section, you need to select the interface and the type of this, which interface and what type or what IP address for which the FortiAnalyzer device is going to provide the redundancy. This is the IP that other device needs to point to send their logs once the cluster is up. So this is your cluster IP or VIP IP or virtual IP, or sometimes also being known as called as floating IP address. Next, over here, you need to add the IP address and the serial number of each secondary device that you do have, and you can keep on adding with the symbol of plus. These are the secondary devices to the primary devices peer list. The IP address and the serial number of the primary device and the secondary devices must be added to each secondary device also. Same way you have to do it on the other boxes. Cluster members, all the cluster members, as I stated it earlier, need to be reachable to these particular IP addresses for the heartbeat messages. As shown in the previous slide also, if I go back over here, it is not mandatory they have to have in the same subnet. They can be in a different subnet also. They can be in different subnet, but the IP reachability has to be there. When you talk about HA as a cluster, the primary device and the secondary device have the same, should have the same group ID. Same have the group name. Name should be same. All should have the same group ID and the password. The priority settings determines the selection of the primary device. You can assign the priority from 80 to 120, as you can see in the diagram also. Where the higher number has the higher priority. Highest is the best. In the last, there is log data sync option is enabled by default. It provides real-time log synchronization among the cluster members after the initial log synchronization is done. In this slide, you can see that the primary selection, HA primary election process. The initial section of the primary device is based on the preferred mode configured or role configured. If the preferred role over here is primary, you can see that, then this device is going to become a primary. So start, what is the preferred role? Primary. Primary already elected? No. Then join as a primary. Very straightforward. If primary is already there, then it is going to join as a secondary. Okay. If the preferred role is primary, which is being configured, then the device becomes the primary device if it is being configured first in the cluster. If there is already an existing primary device, then the device is going to join as a secondary box. The default role is secondary so that the device can synchronize with the primary device. The secondary device cannot become a primary device until it is synchronized with the primary. So the bottom line is, if the primary is available, any new primary is coming, it is going to join as secondary. And if primary is available, the secondary is going to join as a secondary only. Secondary cannot become primary until primary is available. So primary election after failure, you can see that primary fails. At least one secondary is there. No, then the cluster is going to get failed. If one secondary is there, yes. More than one secondary is there, yes. Secondaries have same priority. No, secondary with the highest priority becomes the primary. If only one is there, that secondary will promote as a primary. If it is having the same priority, secondary with the highest IP address becomes the primary. So the bottom line is simple. If I have a cluster and I have two FortiAnalyzers, say for example, one is primary, and this is the preferred role we are saying. And another FortiAnalyzer also joins this. And if its preferred role is also primary, so it is going to join as secondary, because once the primary is being added into the cluster, the other box are going to be joined as secondary only. If the member is joining as secondary and primary is elected, so there is no doubt it is going to join as a secondary only. You see that? If primary is the preferred role, it is going to become primary. But if the role is primary, again you are joining second box as role primary, it is going to join as secondary. Another options. You have 1, 2, 3 FortiAnalyzers. Primary, secondary, and secondary. If primary fails, at least one secondary is there? Yes, there are two. There are more than one secondary is there? Yes. Among them, say for example, the priority here is 100 and the priority here is 90. So the device who is having the higher priority will become the primary. Assume both are having the priority as 100. So if the IP address is 10.1.1.10 and here the 10.1.1.11 is the IP address, so the highest IP address is going to become the primary box. That's how the primary election happens. Next, HA synchronization. To ensure logs are synchronized among all the HA devices, FortiAnalyzers HA synchronized logs in two states: initial synchronization and real-time synchronization. Initial synchronizations are the synchronizations. Just give me one sec. Just give me 1 minute, sir. Yeah. So we are talking about initial synchronization and real-time synchronization. Initial synchronization, the primary device synchronize its log. So we have a concept of primary and the secondary. Initial one is the one in which the primary device synchronize its logs with the new device which is being added into the cluster. After the initial synchronization is completely being done, the secondary device automatically reboots and rebuilds its log with the synchronized logs. And we can see the status in the cluster state pane, that initial log synchronization column. There will be a synchronization column that we'll see that. The real-time synchronization, after the initial synchronization is done, the HA cluster goes into the real-time logs. Actual, whatever the traffic is going, that real-time log synchronization state, which we call as log data sync, is enabled by default for all the devices in the cluster. When the log data sync, when we are talking about this log data sync is enabled in the primary device, the primary device forwards the logs in real time also to the secondary devices. This ensures that the log in the primary and the secondary device are completely synchronized with each other. If the primary device fails, the secondary device selected to be the new primary, we know that. And it is going to continue to synchronize logs with other secondary devices if they are, because as we know that there are 4 devices in a HA cluster can be there. The configuration synchronization, the third one that we have it, the configuration synchronization provides redundancy and load balancing among the cluster devices which are participating. Reports, incident, events, device manager, most relatable settings, everything gets synchronized in the HA cluster. Next. When you talk about HA load balancing and firmware upgrade, FortiAnalyzer supports this concept. FortiAnalyzer supports load balancing. It improves the performance of the following modules like reports and FortiView. So can I say that Fortinet, FortiAnalyzer, HA can balance the load and improve overall performance. It enhances the reports and FortiView section. When generating the multiple reports, if you are planning to generate the multiple reports, the loads are distributed among the different devices in a cluster. The loads are distributed to all the HA clusters. How? In a, remember, round robin fashion. I hope you have heard about it. When the report is generated, the report is synchronized with other device so that the report is visible on all the HA device members. Similarly, for the FortiView, a cluster device shares some of the load when these modules generates output from their widgets. So it's a round robin fashion that the load balancing is going to happen. log in to each secondary device, upgrade the firmware of all the secondary if you wanted to do the firmware upgradation, like upgrading. Wait for the upgrade to be get completed. Verify all the secondary device join the cluster. Verify that the logs on the secondary devices are synchronized with the primary. And in the last, upgrade the primary device. When primary device is upgraded, it automatically becomes a secondary device, and one of the secondary is automatically going to become a new primary. Fair enough. This allows the HA cluster to continue operate during the upgradation of the firmware process also. Next, HA monitoring and troubleshootings. In this particular slide, we are talking about the cluster status. The cluster status pane monitors the status of the FortiAnalyzer in a cluster. Okay. This pane over here displays the information about the role of each cluster devices. The HS status of the cluster, the HS stated configurations of that, if the configuration synchronization is done or not. The following information over here is being displayed. Role, what is the serial number, IP addresses, the host name of the device, the uptime and the downtime, the initial log sync, the configuration sync, and the messages. We can use the CLI command called as diagnose HA status to display the HA status or HA status information. The image on this slide also demonstrates the process. You can see that. Okay. So this is just for the demonstration purpose to understand the commands and all. Knowledge check. Which values check first when selecting the new primary device in the event of the device in the event of the FortiAnalyzer HA failure? The priority. If the priority is tied, the IP address. Which of these modules does the FortiAnalyzer HA cluster synchronize during the synchronizations? Reports. Next. ADOMs. We have already discussed this in manager, a little bit relevant to the FortiAnalyzers. ADOM, we're going to discuss it. Objective. It enables and creates the ADOMs. What we learn over here. Enable or disable in CLI using the GUI. We know that the ADOMs can be created, right? How to create the ADOMs also we know it. We have discussed that lately. And we know that the ADOMs are not enabled by default. By default, only administrator with the super user RBAC, right? Access can enable and configure the ADOMs for us. ADOMs are required if you want to register a non-FortiGate device on the FortiAnalyzer. So this segment is basically with reference to ADOM topic in FortiAnalyzer. So ADOMs are required if you want to register a non-FortiGate device on the FortiAnalyzer. That is the time the ADOM is required in Analyzer. How to enable config system global set ADOM status? We'll do the lab, then it will be more clear. The maximum number of ADOMs depends on the FortiAnalyzer model that you are using. Once enabled, must select an ADOM for all your configured ADOMs like Fabric, Roots, and all. After you log in with the ADOMs enabled, you must select the ADOM you want to view in the list. Like which ADOMs you want to see. Say select an ADOM you want root or you want the ADOM which is being created. How ADOM works in the FortiAnalyzer? Let's try to see that. A global ADOM configuration can operate either in a normal mode or in an advanced mode that we have discussed in FortiManager lecture. The normal mode cannot assign VDOMs, virtual domains, for the same FortiGate device to multiple FortiAnalyzer ADOMs. All the VDOMs must be assigned to a single ADOM. ADOM is administrative domain. VDOM is virtual domain. VDOM is relevant to the devices. ADOM is related to the administrator who can manage what devices. Must assign a FortiGate device and all of its virtual domain to a single DOM. Advanced. Can assign VDOMs from the same FortiGate device to the multiple FortiAnalyzer ADOMs. So your ADOMs can be there in FortiAnalyzers also, same device. Allows you to use the FortiView, event management, reports, function and all. Generally, we take the advanced mode. The image on this particular slide shows you two scenarios, each consisting of the FortiGate unit with 3 VDOMs configured. FortiGate with 3 VDOMs configured. On the top, when you're using a normal mode, it's not possible to assign different VDOMs to different ADOMs. You cannot, in the normal mode, different virtual domain to different ADOMs cannot be done. But in advanced mode, in the bottom, each VDOM can be assigned to a different ADOMs. That's advanced mode, and that is more likely to be get used, more likely to be get usable. How to create an ADOM? Let's have a quick look. Practicals are also on the ways. Creating an ADOM, create a new ADOM. Create new ADOM if default ADOMs do not fit the requirement. We know that option of creating the ADOMs. So on all ADOM page, you can see configured ADOMs that you do have it, as well as default ADOM for all the non-FortiGate devices. You just need to create an ADOM, give a name, what is the type of the particular FortiGate box it is, disk allocation, data, and all this, the quota you can allocate with reference to the devices. FortiAnalyzer, all Fortinet device in a security fabric can be placed in the same ADOM. FortiAnalyzer supports fabric ADOM. You can put every device into same administrative domain also. So that's what is written, security fabric ADOM. Security fabric ADOM means all the devices in one single ADOM. Can contain all devices in security fabric in same ADOM. Security fabric ADOM allows fast data processing, log creation, and it is also a best practice to keep it. Combined result to be present in reports, FortiView, incident and events, Forti security operations centers, device manager, and Forti logs. Disk quota is assigned to fill in the blank ADOM. ADOM has to have this, you see that, disk quota. When you create the ADOM, you have a disk quota, you have to fill it up. Which statement about the ADOM advanced mode is true? You can assign FortiGate VDOM from a single device to multiple FortiAnalyzer DOMs. Simple. Next. RAID. What is RAID? Configure RAID and troubleshoot the RAIDs. RAID is basically a topic comes into the data center worlds. RAID storage world. RAID stands for redundant array of independent disk. Redundant array of independent disk. Okay. So administrating and managing your system allows basically whatever you're gonna administrate it, right? Or manage your system. Also includes protecting your log information. See, analyzer is all about logs, right? And our objective is to basically protect it. Data is everything. In today's world, data is everything. What is data? A piece of information. Logs, events, these all are piece of informations, and it is important to protect it. This can also include or introduce redundancy for your log data. So redundancy of the devices is called as HA, primary, secondary. You can also have the redundancy in your logs by making a copy of the log. Okay, so you have a data, you can copy it. You can say, for example, just for the analogy, you can copy it from C drive to D drive, D drive to external hard disk to your Google Cloud. So you can protect it by making a copy of your logs should your system stop running. The most likely or most commonly used method for high performance storage is RAID. RAID is a high performance storage solution. Stands for redundant array of independent disks. RAIDs by default, and point to be noted, it is not this concept. This solution is not available on all FortiAnalyzer models. RAID combines two or more physical drives into a one logical, like say, for example, you have two firewalls, two FortiAnalyzers, two firewalls combined together to form a single logical firewall, correct? Single logical firewall, two FortiAnalyzers, single logical FortiAnalyzer. In a very similar way, if you have two hard disk HDD1 and HDD2, two hard disks can form a single logical unit. And that single logical unit concept and solution is called as RAID. So basically RAID, what does? It enables you to distribute your data among the multiple hard disks. You have multiple hard disks, your data can be distributed in different hard disks. The RAID distribute data across the drives in different ways. And those ways are called as different levels, RAID level. Combines not supported on all the models. RAID concept combines multiple equal side disk drive into a logical unit. Data is distributed in different patterns in different ways, and each ways or pattern is called as RAID level. Require multiple identical devices, which is important. Same drive, same hard disk required. RAID is not a replacement for backup. Point to be noted. It's a solution. You should still make up log backups even if you have employer RAID. It's not a solution to the backup. That's what we are trying to understand here. Next. Basic RAIDs has two types of operations. We have an operation called as mirroring and stripping or striping, however you want to pronounce it. Mirroring makes identical copies Basic RAID has two types of operation, mirroring and stripping. Mirroring makes identical copies of the data on two separate physical drives. Mirroring makes identical copies of the data on two separate physical devices. That means you have two hard disks. Here you have, this is HDD1 and this is called as HDD2. So whatever the data is here, the same data will be replicated over here. That is called as mirroring. Striping means combine two or more drives into a single logical drive and stores data in chunks across all the drive. That means striping meaning is you have 3 hard disks. You have this data. You chunk the data into the small pieces. The first piece will go here, second piece will go here, third piece will go fourth here, fifth here, sixth here, seventh here, eighth here, ninth here, like this. In the striping, if any one hard disk goes down or any one hard disk gone, your data will be corrupted. Minimum RAID is a mirror or stripe of the two. Let's start from there. This is the basic RAID level. RAID has two types of operation at the base. You can mirror it or you can stripe it. Stripe means chunk the data and put it in different hard disks. Mirror means, again I'll repeat, this is your data. Chunk the data into the small pieces. This is mirroring on the top. All the data is in one hard disk. From one hard disk, you are copying it to the other hard disk. This is called as mirroring or copying. Striping means you have multiple hard disks are there. One goes in this, second goes in this, third chunk data in this, fourth year, fifth year, sixth year, like this. Not all RAID levels behave the same way because they are different concepts. Some do mirror, other stripes, other do both. Some includes parity, distributed parity. Some can handle one failed drive, others two can handle it. Too many failed drive result in the data loss. This is also an important thing. RAID can be hardware based, RAID can be software based. Acha, now what is the advantage of mirroring? What is the advantage of mirroring if you have two hard disks? Okay. So you have your data all over in this and it has been copied in the another data also. So if your one hard disk failed down, so another hard disk is still there and your data will be saved. What is the advantage of stripping? If you have multiple hard disks, your data is being copied at the same time. So here read and write operation is very fast. Right here, read and write operation is very slow. But here data will be saved. Here data is not being saved. So RAID can be hardware based, RAID can be a software based. Hardware based is recommended, software based is not recommended, as simple as this. And we also say is that always use hardware based. What are different levels are there? Let's see it over here. Again, not all FortiAnalyzer model supports RAID. Check the model specification which you are ordering it. RAID 0, RAID 1, RAID 1 plus pair, RAID 5, RAID 5 plus pair, RAID 6, different concepts are there. That you can learn about it in this way. So RAID 0, A1, A2, A3, A4, A5, A6, A7, A8. This is called as striping. See, one chunk data here, another chunk data here, A3, A4, A5, A6, A7, A8. Two disks are there. This is striping. Read write will be fast. RAID 1 is mirroring. So here in RAID 0 with two 1 TB hard disk, two hard disks are there, 1 TB each. So total you will get 2 TB. But when you are doing mirroring, you have two hard disks of 1 TB each. You will get total space of 1 TB only. Then you have RAID 5, A1, A2, A3, A4, B1, B2, B3, C1, C2, C3, CP, DP. These are called as parities. These are called as parities. Parities is basically the things where it is being stored up. Then you have dual parity concept and more in details. Then you have RAID 10, RAID 50, RAID 60. Higher the number you go, more expensive solution and more guarantee that your data and logs will be saved. That's the bottom rule. RAID is going to provide security to our data traffic. So you have RAID 0, RAID 1, RAID 5, RAID 6, RAID 10, RAID 50, RAID 60, RAID 100 is also there. So on the RAID management page, you can see that on the RAID management page, you can view the status of each disk in the RAID. What are the different disks you have? What are the disk status is there? disk model, Samsung hard disk, you can see that, and so on and so forth. So this status can be one of the following: ready, functionally normal, rebuilding, initializing, verifying, degraded, hard disk is no longer being used by the controllers, inoperable. In order to view RAID failures or hot swapping, the option is system or alert message consoles are there. Failed disk must be replaced to keep availability and the performance. There could be a possibility that hard disk can be also crashed. So if the FortiAnalyzer device supports that concept, hardware RAID on the software RAID, we have discussed about that earlier. So you can replace the disk while the FortiAnalyzer is still running, which we call as hot swapping. Hot swapping means still running and you can replace the things. Software RAID, you must shut down the FortiAnalyzer prior to exchanging the hard disk. Its hot swapping is supportable with hardware RAIDs only. If you want to diagnose the RAIDs, you have the commands in front of you. Diagnose system RAID status, diagnose system RAID hardware info, disk health, disk errors, disk attributes. The RAID 10 level compromise with data format. It's mirroring and stripping. It's a combination. It's a combination of RAID 1 and 0. What must you do if a hard disk on the FortiAnalyzer that supports RAID fails? Shut down the FortiAnalyzer and replace the disk. Why? Because we are talking about software RAID. If it is a hardware RAID, then hot swappable disk is available. And this is for the lesson. So tomorrow we'll talk about, sir, device registration and communication.